Hello everyone. In this video we're going to go over every answer in the Chapter 9 practice test. You can see that I have the data file for the first set of questions loaded up. You're going to have to do that as well, obviously. You're going to need two data files. This will be the first, this data set will address the first few questions. First thing you want to do is generate your value labels. So in this example, for gender, you want to change that to male, change the 1 to male, and change the 2 to female. And then you want to do that for sign as well. So you double click on sign, and 0 in this example means no sign, and 1 is there is a sign present. You're definitely going to want to do this because it'll make the output much easier to read and interpret. Now we're going to do a two-way ANOVA here. So we click on ANOVA and then ANOVA again. And I'm just going to walk through all of the stuff you need to do to answer all of the questions here and go through the output as the question comes up. So you're going to put the two independent variables, in this case gender and sign, in the factors box, and the dependent variable here. You want to get omega squared, so you click on that. You want to get post hoc tests. Post hoc tests. And you pop each factor over, each IV over, and the interaction over. You want to make sure to get the correct p-values. It will default to giving you a Tukey or HSD p-value. You do not want that. You want the non-corrected or no correction p-value. Make sure you remember to do that. You're going to want D and the confidence interval around D. You're also going to want to get graphs and the specific means for each condition. So you'll want to click on estimated marginal means, and you'll get a graph of the main effect of gender by putting gender over there. Then you want to add a new term, pop sign over there, and now that will give you a graph of the main effect of sign. And then of course you want a graph of the interaction, so you click on new term again, and then you just pop both of these over in the same box, and then that will give you everything you need. The last thing you need is to make sure to remember to click on marginal means tables. That will give you the means for each condition that you're going to need for this analysis. Now I'm going to try and fit as much as I can on my little screen here. Pretty much see everything. The first question asks us to just find the statistical information for the interaction. So you're going to find this information by looking at this ANOVA source table up here. The numbers in the parentheses are always the degrees of freedom. So in this case, this is the degrees of freedom for the interaction. So it's the first number is across from the interaction term, the gender by sign. So it's 1. The next number in the parentheses for the degrees of freedom is 124, which is the residuals. That's also called the mean square error, because residuals is another term for error. And then after the equal sign is what F equals. And of course you have 3 F's here, but the F we want is the one for the interaction. So it's 5.46. And then here's the p-value for that, 0.021. And then the mean square error, as I said, is the mean square residual right here. And then finally the omega squared, which is again on the interaction line under omega squared. So that's where you find all of that information. The next thing you want to do is find the simple effects for the men. So what you want to do is you want to come down to this post hoc comparison for the interaction. And the question asks, find the simple effect analysis indicated for when men used, for men, whether or not the sign was present or not. So you want to go to male, no sign, and then compare that to male sign. All right, so this is the line that you're looking for. And you can see that you have a difference of 8.25 milliliters of soap. And it's negative simply because what it's doing is it's taking male no sign, the mean for male no sign, and then subtracting from that the mean from male sign. So if it's negative, that means the male sign had a higher value. So in this case, the males used 8.25 milliliters more soap when the sign was present. And that's how you fill those blanks. And then the next one is asking you to interpret the p-value for that effect, right? So is the difference of 8.25 milliliters large enough to be unlikely to be due to sampling error? And this p-value suggests no, it's pretty likely to be due to sampling error. The p-value of 0.49 is pretty large. So this is very likely, this difference is very likely to be due to sampling error. So the interpretation here is that the sign didn't really have a very compelling effect on the male's hand washing behavior, or their use of soap at least. And then that comes down here. This p-value suggests that these data are consistent with the null, that the sign didn't have much of an effect. Next one, we want to do the same thing for females. And so we come down to this post hoc comparison table again. We have female no sign, female sign. We see that when the sign was present, they used 48 milliliters more soap. And that difference is definitely compelling looking at this p-value. So that's how you fill out 5 and 6. There is the p-value. So it's really important that you learn how to use this table, right? So you have to make sure you pick the right comparison. There's lots of comparisons here. This line is comparing male when no sign was present to male when sign was present. And this one is comparing female with no sign present and female when sign was present. And then in the middle, you have to be a little bit careful. So this second line is comparing male with no sign to female with no sign. And then you can find the p-values and all that. So you'll need to be able to find the appropriate comparison that the question is asking for. All right, moving down. Choose the best interpretation for the p-value for the simple effect of women. Well, again, this p-value is very compelling. So this is, again, strong evidence against the null. It looks like the sign had a strong effect on females' use of soap. Now we choose the best summary for the interaction. There's strong evidence that signs increased soap usage for women. The data is consistent for the null hypothesis in the men's bathrooms. And again, that is the interpretation of the interaction based on the simple effect for females and the simple effect for males. The next question is asking us to talk about the main effect of gender, and we want to fill in the stat information. So we jump all the way up here and we go to the ANOVA source table, and we find that on the gender line, we find most of what we need. We're also going to need a little bit from the residuals line again. So the degrees of freedom are, again, 1 and 124. The F value is 22.7, very large F value, which is why we have a very small P value, which comes next. Then your mean square error is the same value as we got before, mean square residual. It's right here. And then the omega squared. Oops, the omega squared for gender is right here. Pretty large omega squared there. Choose the best summary for the main effect of gender. Well, you could also come down here and look at this post hoc comparison for males and females. You can see that there was a 41 milliliter difference in soap usage, females using more. And that is a very compelling difference given this p-value, and the effect size is quite large. It's 0.8, which is a large effect. So again, women used more soap. How strong is this evidence? It's strong because this p-value is very, very small. and the effect size is large. I didn't ask a question about effect size, but I could have, and the effect would be large. The next one is asking you to find the, or interpret the main effect for the sign presence versus absence. Again, you want to go back up to the ANOVA source table. You want to use the line for sign. And again, 1 and 124. Here is your F value. Here is your P value. Here is your mean square residual or mean square error. And then here is your omega squared for the sign factor. And then your best interpretation for the sign. Again, we can come down here to look at the sign information. When the sign was present, overall, collapsing across males and females, people used about 28 milliliters more soap. And this p-value is compelling, and the effect size is medium in size. So when people use soap, they use more soap when the sign was present, I should say. And again, we have compelling evidence for that because of this p-value. It's very unlikely that that difference of 28 milliliters was caused by sampling error because this p-value is crazy small. Okay, and then how strong is the evidence? Again, it's strong, I said, because that p-value is crazy small. Now, of these three effects, which is the most important? The interaction. If you have a significant interaction, that's generally going to be the most important effect. If you think about the pattern of data we got, it's suggested that the sign was really only effective in changing the behavior of the females. It didn't really have much of an effect on males. So the effect, overall effect that said that people used more soap when the sign was present, that was really kind of a misleading effect because that didn't really happen for everyone. It really just happened for females. So again, the best description of the overall pattern is generally going to be the interaction. Next question is talking about the methodological rigor of the study, and it's talking about which of the following things would increase your confidence in the results. And really, the answer is all of them. If you increase the number of bathrooms used, again, there's something weird about one or more of the bathrooms. So the more bathrooms you use, the better sample you have of bathrooms, right? And then you want to monitor the people going in and their age just to make sure, there might be a difference in age in hand washing behavior, perhaps. And then finally, you want to just make sure that you have the same number of sinks, basically the same layout of bathroom to make it a fair comparison. Okay, and so this one is this question 17 is a little tricky, and that what would you do? So I interpreted the data a little earlier saying that the sign really only had an effect for females. So a reasonable answer might be, well, since it didn't really impact male behavior, why don't we save money and just put the sign in the female bathroom? And that actually, based on the data, that seems like a pretty reasonable answer. However, if the signs are really inexpensive, then you're not doing much harm, and it won't do any harm if you just put the sign in both. So I should have pointed out these graphs too. This is the graph of the interaction. You can see that for males, when the sign was present, they did use a little bit more soap, but that difference was so small that it was unlikely to be, it could very well have been due to sampling error because it was so small. You had a large p-value there again. But it was higher, so it's not doing any harm to just put the sign in there for them. Now here you can see for females, having the sign present had a very large effect. So it's clearly doing some good there. So at a minimum, you'd want to put the sign in the female. But again, if it's inexpensive, it's doing a little bit better. It might just be due to sampling error, but it's not any harm to add it. So sure, add it to both. Now the next set of questions deals with the other data set. So I'm going to pull that up. And again, you want to do your labels here. So I have to make sure I remember which code is used here for these. Yeah, so 1 is exercise, 2 is no exercise, 1 is meditation, 2 is no meditation. So we want to go to 1 being exercise, 2 meaning no exercise, and then meditation. For 1, and 2 is no meditation. And it'll say this in the question somewhere. Okay. So now that we've got the data coded correctly, we want to run our two-way ANOVA. So we go ANOVA and ANOVA. Our dependent variable in this case is optimism. And our 2 factors are whether or not people are exercising and whether or not they are meditating. So again, we're going to have 4 groups. People who are doing both, people who are doing neither, and then people who are doing one or the other of them. We want to get omega squared. We want to get post hoc tests. And we're getting all of the factors, the main effect of each factor and the interaction between them. We want Cohen's d. We want the confidence interval. Of course, we always want to get the uncorrected p-value, not the Tukey corrected p-value. We also want to get the estimated marginal means. You can pop to get the main effect of exercise graph. It's giving us that. We also want the main effect of a meditation graph. So popping that over is going to give us this. And if you get comfortable looking at these, you can kind of estimate the size of the p-value you're going to get. The more the overlap between these confidence intervals, the more the overlap, the larger the p-value. We also want to get the interaction term, so we will pop both of them over there. And the interaction is very helpful with the interaction graph is very helpful with helping you interpret the meaning of the interaction. Just by looking at this, you can sort of guess what's going to happen here. All right, and again, you also want to make sure you get these marginal means here. We didn't use these for the first set of data, but we will for the second. So you want to make sure you know how to use them. Okay. So let's get this back set up again. Okay, almost there. All right, so the first question is talking about which of these is the best way to, or which of these is the possible interaction. Well, the interaction is always between the 2 factors, the independent variables. So we're trying to see if exercise and meditation interact to influence optimism. So it's the exercise by meditation interaction. You can't have an interaction with the dependent variable. It's the IVs interact with each other to influence the dependent variable. So that's how you'll know the correct answer for this one. And then this is very much similar to what we've done above in the previous example. You want to find the right statistical information for the interaction here. And again, you're going to go to the interaction line. So the degrees of freedom are 1 and 92. Here's the F, here's the P, here's the mean square residual or mean square error, MSE, and then the omega squared. Now you want to compute the simple effect for the exercise, no exercise groups. So you want to go down to here again, the simple effect for the meditation across an exercise. So you want to compare groups that have both meditated, right? We compare groups that have both meditated. So here's a group this group is meditation, exercise, and we want to also do meditation, no exercise right here. And so if we go over, you can find that p-value is about 0.04 right there. Okay. Okay, for question 21, you want to find the means for the simple effect of exercise across the meditation, no meditation groups. So people are, in the two groups you're comparing, they're both exercising. So we want to compare the meditation exercise to the group that also exercised but didn't meditate. So the two means we're looking for are 5.92 and 4.21. For 21, we want to compute the simple effects for no meditation across the exercise and no exercise groups. So again, we want to come up here. So we want no meditation, and we want across the exercise, no exercise groups. So we have no meditation, no exercise, or excuse me, here's the exercise, no meditation. And then we also have the no exercise, no meditation. So this is the line we're looking for. And you can see that the p-value is 0.77. Next, which means are being compared by the simple effect of the no exercise. So we want to compare the two groups that are simple effect for the two conditions that are not exercising. So meditation, no exercise is 3.79, and the no meditation, no exercise is essentially 4. Okay? And now we want to fill in the blanks for the main effect of exercise. So we go way up to the top again. And for the main effect of exercise, we want to go right here. And so we have 1 and 92 are the 2 degrees of freedom, our f value, our p value, our mean square residual, and then our omega squared. And that's where you get all those numbers, which means are being compared for the main effect of exercise. And you want to pick 2. So the main effect of exercise, you can go down to this table here, main effect of exercise. So it's 5.06 and 3.89 or 3.90. And now you want to find the statistical information for the meditation. Again, you go right up here to the top. Here is the meditation line. So it's 1 and 92. Here's your f value. Here's your p value, mean square residual again, and then your omega squared. Which two means are being compared by the main effect of meditation is right down here. So here's the exercise main effect means. Here's the meditation main effect green means. The meditation and no meditation means right there. Now choose the best summary for the interaction. Well, again, I think it's helpful to look at this and then also look at the simple effects analysis. So let's take it, here's the correct answer, and let's take it a sentence at a time. There was strong evidence that people who exercised and meditated had higher optimism scores than people who exercised and did not meditate. So that's really talking about this comparison right here, comparing the people who meditated to the people who didn't meditate, but both groups exercised. And it's saying that this group had a higher optimism score than this, and it kind of reflects that in the graph. But how do we know that that is strong enough to be compelling, that this difference is strong enough to be compelling? Again, you would go up and you would compare the people who exercised and meditated to the people who exercised who didn't meditate. And here's the p-value. It's small enough to be compelling. And then again, you can look at the effect size, and it's a 0.7, which is close to a large effect, right? So again, this is the line that gives us information to support this first sentence. The fact that meditation and exercise group did better than the people who exercised without meditation. And then there's kind of a different story for the people who did not exercise. You can see that here. For the people who didn't exercise, the people who meditated did slightly worse in terms of their optimism. But when you go up and you look at the graph for that, no exercise, meditation, no exercise, no meditation, you're comparing those groups, you can see that that p-value is very large. It's not compelling. That difference is likely just due to sampling error. This difference here is probably just sampling error. So that's what this second sentence is reflecting. For those who did not exercise, those who meditated had slightly lower optimism scores than those who did not meditate, but these data are consistent with the null because this p-value is so large here, and so this difference is probably just sampling error. Choose the best interpretation for the main effect of exercise. So you're going to go up here to the exercise graph, and you can kind of look. It says, looks like people who exercised had higher optimism, but is this difference, is the p-value small enough to be compelling? So there's a couple places you can look here. I would look at the post hoc test for comparing exercise and no exercise. You can see you have a very compelling p-value here. So people who exercised were more optimistic than people who did not. And there's strong evidence against the null because this p-value is 0.2, which is, again, 0.1 is considered very strong evidence. And this is pretty close to 0.1, or 0.01, I should say. 0.01 is considered strong evidence. And this is 0.02. So you can see that this is pretty strong evidence. And the effect size was moderate because the D is close to 0.5, which is a moderate effect. Now you want to choose the best summary for the main effect of meditation. So again, you can see that meditation led to slightly higher scores, it looks like. There's a fair amount of overlap, but let's go up and look at the p-value here for the meditation. You have a p-value of 0.34, or 0.14. And that's not very compelling. It's weak evidence against the null. So overall, those who meditated had higher optimism scores than those who did not. However, this difference was small and only had weak evidence against the null hypothesis. You could look at this and say the effect size is smallish, and maybe that's a large enough effect that you have interest in it. Maybe it's important. If you wanted to find out if this effect was a real effect in the population, you'd have to run the study again with a larger sample size to maybe see if this effect is a real effect or if this is just a statistical anomaly here. So again, not very compelling evidence with these data, right, based on this. So based on this, would you suggest that meditation is helpful? The best answer here is yes, but only for people who exercise. And again, this is an interpretation of that interaction. It doesn't look like meditation was helpful if you don't also exercise. But if you do exercise, meditation seems to be very helpful. So this is the best answer. You don't want to say, yes, it's helpful, because it's not helpful for everyone. Again, the interaction is really the best answer here. Now, rather than run through every single one of these, because this video is already starting to get pretty long, I will just show you here what the answers are, and then just briefly talk about how you would interpret or how you would choose between these things. So the answer here is independent T. You want to use an independent T when you have two different groups of people and you're comparing the mean performance of one group to another group. So this example, there's two groups of people and there's different people in the two groups. The next example is a two-way ANOVA. And here what you're trying to do is you're trying to identify how many groups you have. Really, if you look at this, you have 2 different factors and 4 different groups, right? It's kind of like the examples we had here. We have 4 groups here. This is the same thing. We have 4 groups. We have a high and a low group in one condition, and then we have another factor that also has 2 conditions in it. So that creates a 2 by 2. And then here we have a one-way ANOVA. We have 3 different groups of people, or 3 different types of conditions, I guess, 3 different conditions, 3 different foods. And whenever you have 3 different groups you're comparing, you know it's going to be a one-way ANOVA. You can't have a 2-way ANOVA if you only have 3 groups, because the smallest 2-way ANOVA that's possible would have 4 groups. Again, independent samples T is going to be comparing 2 groups, and that's what's reflected in this example. A single sample T is going to have 1 group that you're comparing to some value of interest. Here, the number is the mean score of 5. And so you're comparing one sample mean to a score of 5. And in this case, you don't know the population standard deviation for the dependent variable, so you're going to want to use a single sample T. And then again, we have a 2-way ANOVA. We have 2 different factors here, and that's why we have 4 different groups. That's why this is the right answer here. Related samples T, you're comparing 2 means, but they're coming from the same people measured twice, so that's why this is the correct answer. And again, single sample T, you have 1 sample mean and you're comparing it to some value of interest, and you do not know the population standard deviation. All right, that's going to wrap it up. I hope you found this helpful, and if you do have any questions, please contact your instructor. They'd be happy to help you.